Right, once again, morning, guys. Thanks for making the early morning call. I know 9 o'clock's a bit of an early one. Be that as it may, I think most of us are here. I am recording this, so if you want to review it again, I don't think you will, though. And for the guys that aren't here, they can review it. Obviously, I'll put it up onto the YouTubes. Okay, so we are tackling today Learning Unit 7. Okay, this is one of these learning units where I'm not going to be able to actually teach you much. In fact, at this stage, much of my job is done because I'm very much more mentoring at this point here. A lot of the stuff that we're going through now is really just grunge work. You just got to literally work through it, make your notes, whatever it is that you do. There's nothing, any sort of new concepts that I'm teaching you here. So it is sort of horrible work. It's not my favorite, this at all. It kind of very much falls into the theory of programming sort of arena. Obviously, if you want to ask a question, just go ahead and ask. You don't wait until the end. Just go ahead and ask. Okay, so we're talking today about software development on the software development cycle and the types of systems that have been developed by companies, so mainly larger companies, of course, that are building large-scale systems. I mean, you can imagine what's involved in writing, say, versions of Windows. I mean, that's insane. I mean, you've got tons of programmers. They're all working on different pieces of the code, and you've got to make sure that whatever code they're writing will be compatible with what everybody else is writing. I mean, those big projects are massively complicated. And it's not just Microsoft. I mean, it's any big. Even nowadays, some of the larger apps that are around, and it's not just a one-man band. There's a couple of people doing it. It's even open source stuff. These big Linux, for example. I mean, that's even harder because you don't even have all your programmers in one building. They're all over the world, so you've got added complications of that sort of thing. So coming out of all this sort of development work that's been done over the years, you've kind of got these sort of models that have come about. Okay, I've written a lot of software. I have never purposely followed any of this. Okay, I mean, obviously as a one-man band, you do your thing. I would say if I had to fit this in, my sort of style would be much more the rapid application development sort of stuff you'll see later on in this chapter. But I've never physically thought to myself, oh, I'm going to develop this program using the agile method. You just don't do it. Not as a one or a two-man show anyway. Okay, so obviously the reason behind developing these models, we can see I'm on page 208 in the book. The reasons for this, you could probably ad hoc this if you needed to, if the question came up. But obviously, there's things like you want the software to be correct. It must be reliable, robust, user-friendly, efficient, readable, portable, and you want it to meet all the sort of current standards. It's sort of standards of things like in Java, naming conventions, that sort of thing. Not so much really in proprietary code. Well, I guess it's still to a fair extent in proprietary code, but in open source code, definitely you've got tons of people that are working on it from all walks of life, different levels of education, stick to the standards. That's why they call them a standard. And obviously proper documentation. Documentation is crucial for these big projects. People come and go on your team. You need people to be able to pick up where they left off without having to completely reinvent the wheel or rewrite that code because you don't know what they were doing. So those there are sort of the criteria behind a good program, and those are sort of what you are aiming towards if you are a developer. So they came up with this thing, you'll see in the book they refer to it as SDLC, Software Development Life Cycle. Okay. We've done, you've done a little bit of this before. In grade 10, you did these sort of IPO diagrams, very, very simplistic stuff. You kind of, these are just sort of the tools that you would use during different stages here. IPO diagrams, so that's obviously input, processing, and output. You work out what's going to go in, what's going to go out. And in fact, when you design databases, for example, you never design a database from what you're putting in. You always look at what you want to get out, because what you want to get out determines what you need to put in. Often you'll put stuff into a database that no one ever looks at. So it was purpose. You don't even needn't even have put it in there. Okay, so IPO, we've seen that before in grade 10. Something that might be a bit new for you, but it's kind of makes sense when you think about it. It's this thing called noun-verb analysis. The idea here is that obviously because of the nature of object-oriented programming, often the names of classes will be nouns because they are a class. Okay, think of like the math class. Math is a noun. In fact, color, the color class, color is a noun. So most of the sort of class names are going to be nouns, and many of the method names are going to be verbs. Get this or set that, or add this or update this. These are what your methods are. Helper methods, getters, and setters are all kind of going to be doing words more often than not. So often, if you do this sort of noun-verb analysis, you're going to see where the methods are and what the class names are, just based on what types of parts of speech they are. So that's quite interesting. We've done UML diagrams before. Okay, so I'm moving on here towards page 210. I will send you some updated stuff for UML diagrams that they're sort of bringing in this year. So I will let you have those sort of updates. When I went to the conference earlier in the year, this was one of the things that they were discussing. There's just some small changes in UML diagrams. The reason they're doing it is they're making it less Java-y. So they don't, the people that weren't doing Java, they didn't want the word constructor in there, for example, because in other languages, it might not have constructors. So they're making them less Java and kind of a little bit more generic. TOE charts, also very kind of simple. These are these task objects and events. You kind of just what task you've got to do, what object are you going to use to achieve that task, and what event are you going to attach that to. Obviously, a lot of stuff you do is event driven, and what event is going to trigger that particular piece of code to run. And then the simple use case diagram. So your code is is put into different functional blocks. For example, there's a little thing there about a restaurant: eat food, pay for food, drink wine, cook food, and kind of who's doing what. So who's going to be interacting with different parts of your program. Okay, so those are kind of just tools, some tools that you're going to use sort of going forward here. Then what they're going to do, so what they do now in the book is they kind of then move into 4 different models, okay, 4 different of these SDLC models, these software development life cycles. And obviously the whole idea behind these things is to try and get good working code as fast as you can, because obviously time is money. The longer you take to develop these things, the more money you got to pay to your programmers and that sort of thing. So the idea is you're trying to get to an endpoint that's acceptable to the customer, it's reliable enough and cheap enough, okay, and as bug-free as possible. And that's kind of what these models they all aim at, that sort of thing: speed, reliability, cost. So here in the waterfall model, you can see it kind of, there's just different levels. You can, in fact, the picture that they've got there, and then the text they give you following this doesn't quite match up with the picture. It's kind of slightly more modified, but the picture kind of gives you an idea, right? So you've got the requirements section, where the customer themselves, they come up with what their requirements are. What do they want this piece of software to do? And then the code is going to start sitting with them and going through this analysis to kind of see how they're going to do bits and pieces. Then they're going to go into the design phase of it. And obviously it's an iterative process. So once a design, you go back to the analysis, see if you are doing everything that it needs to do. So there's kind of a feedback loop there. And that's one of the things that this waterfall model is. One of its characteristics are these feedback loops. And so as you're going down the chain, you're constantly looking back to see, have you fulfilled the previous criteria, the tasks and the criteria in the previous task. So I'm definitely not going to read this. I'm not going to waste your bandwidth here because we can all read. Sorry, excuse me. So then they just say that, in fact, that at the top of page 213, I suspect a lot of you have actually seen that cartoon before. It's been around for years and years, probably more than 15 years ago. I first saw this thing. It's actually quite funny when you see, like, it starts on the top left, what the customer, how he actually explained what he wanted, and then kind of the stages it went through, and actually what he needed. Quite humorous. Okay, so you can go through the stages of this waterfall model. Like I said, its characteristic is it's kind of a layered approach with feedback loops. Okay, so the types of questions you get in exams are that sort of thing. Let's say compare the waterfall model to an agile model or something like that for 6 or 8 marks or something. So the idea is you just come up with 3 facts or 4 facts about each one. 2 advantages, 2 disadvantages of each. It's that sort of question you're going to get here. They're definitely not going to say to you, design this piece of software using this type of model. It's not the type of thing you get. It's normally sort of a contrast and compare type questions. Those are if it comes up in a paper, that's the type of questions you get on this. Okay, so you can go through that and you can make your notes. Like I said, these aren't going to exactly the requirements is there, but then you're going to see they go into specifications phase, okay, and then they've got analysis, system and software design phase. I call it by slightly different names. It's just a slightly modified version of it, but ultimately it is the same sort of thing. Okay, so that's through pages 214 and 215 and 216. Okay, so that's all to do with the kind of the theory behind the waterfall model. Then on page 217, and this is I would say the meat and potatoes here, the type of question you're going to get asked is in this area would be the advantages of waterfall model and the disadvantages of waterfall model, right? And when you would use it. So you can go through that. Just make your notes from there. Okay, the next model, the second of the 4 models that they propose here in the book, or that they're showing you, is called the incremental model. Okay, the incremental model, that is much more of a kind of a realistic way that people do approach this in writing software. Myself, if I'm writing software, I tend to tackle it in this sort of way. And one of the characteristics of the incremental model is you tend to get your software out faster. So you get smaller bits of your software out faster, and then you kind of test them while they're out there, and then modify sort of on the fly. And that's kind of a characteristic. It's much more of a faster type of development cycle. This, so you can go through here. You'll see what the advantages and disadvantages are of that. The entire project can sometimes take a bit longer. Okay, so sometimes it can be a bit more expensive and that sort of thing. You'll see the 4th model that we tackle is called the agile model, and that is a type of incremental model, but it's actually quicker. But you can go through here once again, make some summaries for yourself, a couple of advantages and disadvantages of incremental model, and kind of what is its main talking points. Okay, it's kind of more aimed at, like I said, a faster development cycle. The 3rd model they put forward here, okay, I'm on page 219, is this rapid application development, okay, RAD model. RAD, or rapid application development, has been around for quite some time. Like I said, the idea is you want to try and write your code as error-free and get it out to market as fast as possible. For one, to actually start making some money because you're now selling the app or the program, whatever it is. And 2, that you're not paying your developers as much because they're not there for years and years. So the RAD model, you can go through that. Now, RAD model, it takes a slightly different approach. RAD model is very, very much faster. The idea is like it's like taking a handful of darts and throwing them at the dartboard and hoping some of them hit the board, right? The idea is you just throw some software out as fast as possible, and then kind of develop it while it's in use. Okay, that's sort of the whole idea behind this. That's the R, the rapid part of rapid application development. It's pretty much its goal is to get something out there as fast as possible. Often you don't make friends developing like this, because the people that do, especially get the early versions of your software, end up hating you, because they pretty much end up, the early adopters are pretty much debugging your code for you, really. But yeah, that's rapid application development. So with the accent on the rapid part. So you can go through that, the different phases of that, and its advantages and disadvantages. Okay, it's on page 220. Just make some notes there, and then you'll find that the model that's kind of used by most companies. In fact, when you're looking for a job, they will often say to you they're looking for an agile developer, or a developer that's working in an agile environment. And that's this last model here, which is the agile model. Like I said, it is a sort of a derivative of incremental model, but it's kind of a hybrid, I guess, between just full-on rapid application development, or putting a little bit more thought into it. So and spending a little bit more time with it. So it is sort of the process of choice. It's the SDLC that most big companies would be following, sort of an agile approach to their software development. So you can go through that and see what the advantages and the disadvantages of that are, and when to use it, etc., etc. I'm on page 222. Okay, so this is the last one. They got a bit of a table at the end there, where they kind of put agile up against the waterfall method. The waterfall obviously is the first one that we had to look at, and then they compare them there as to sort of which one is best. So you can see there the distance between the customer and the developer. Waterfall long, agile short, because you're kind of dealing almost face to face with your customer. Time between specification and implementation. Waterfall long, because it kind of works its way through these stages right into the end, and adoption only comes right at the very end in the waterfall model. Whereas with the agile model, you're starting to get code out very early on in the process. Okay, so you've got a much shorter term there. Time to discover problems. Waterfall much longer, because you've got to wait until it's developed, get it out, wait for people to see the problems. Agile, you're kind of developing as you're going along, you see, so you can put out the fires as and when they burst into flame. Project schedule risk. Waterfall is high. Project schedule risk, they mean what is the risk of overshooting the project time limit on these things. Waterfall quite high. Agile is lower, because you're getting a lot more feedback as you're going along, so you can cover the time quite quickly. And the ability to respond quickly to change. Waterfall low, because it's kind of working its way through these levels, whereas agile, as its name suggests, it's quite an agile method. So you can put these problems, you can put the fires out real quick. Okay, so like I said, this section here, it's just a bit of reading and making some notes. There's nothing new that I can teach you here. No new concepts anyway. Has anybody got any questions? Yeah.